Okay, so coterminal angles, two angles in standard position are called coterminal if their side coincide, which means this. So if I start with an angle right here, let's say the angle in standard position is this in the first quadrant, this is theta. So what I'm looking for is if I am finding a coterminal in a positive direction, then I want to search for an angle that after a certain rotation or certain angle rotation, I come back to where I start. So this is the terminal side of the angle, and this is initial side of the angle. Okay, so I'm going to continue and come back. So I come back to the same spot. So that will require adding 2 pi to the angle. So that means if theta is in degree, let's say theta degree, then I will add 360 to find a coterminal. So this is coterminal to the angle theta. If theta is in radian, then I will just add 2 pi and find a coterminal theta radian. So to come back to the same spot, it requires that we do a full revolution and match the terminal side and the initial side. So for instance, another example, if I have, let's say, an angle right here, so this is like angle theta. So now let's see in a positive direction what is required. So we're right here, this is terminal side, and I have to do this. I have to go around and come back to the same spot, and that will require 360 degree or 2 pi. Okay, so to find the coterminal angle in positive direction, we're just going to add multiple of pi. So I'm going to say theta plus 2 pi k, which means 2 pi k means multiple of 2 pi. I'm adding multiple of 2 pi to find the coterminal in a positive direction. Now, to find a coterminal in a negative direction, then I have to do this. So let me erase this so I can do. Now, this is the same. Okay, this was the angle, right? And what I will do now is, because I want to do in negative direction, so I will just starting from this point and just travel in the negative direction. So this is a negative direction, and I come back to the same spot, and that is negative 2 pi or negative 360 degrees. So now in negative direction, so this is, let me just say positive here. In negative direction, I will just have to do theta. So if it's degree, I will do 360 degree. If it's radian, then I will do negative 2 pi. So in general, then you will just, so to generalize this, so I will just, to generalize this too, I will just do theta minus, this is minus 2 pi k, just like I did it over here. So in summary, we're adding or subtracting multiple of 2 pi or multiple of 360 degree to find the coterminal angles. So that's what I want to say. Okay, now next. Next, we will give you guys a couple examples here. So let me erase this first. Okay, so next I'll give you guys a couple of examples. Okay, so these are 2 examples. Okay, so find angles that are coterminal to 30 degree. Okay, so what I will do, either add it, okay, this is degree, right? So since this is degree, then I'm just going to add, subtract 360 degrees. So for part A, I will do 30 minus 360 degree, and that will be negative 330. So that's one coterminal. Or I can do 3 plus 360, which is 390 degrees. So that's just just one, right? You can keep on doing this if you want to get more. So I can, so let's say to find another one, I can just do negative 330 and then minus 360, which is negative 690. This is another coterminal. So these two are negative coterminals. And then to find another one, so I will do 390 plus 360, which is 750. So that's another positive coterminal. So you can keep on doing this to find many more. Now for part B, since the given angle is in radians, so then I will just do minus 2 pi, okay, to find a negative 1, which is 3 times 2, that's 6. So pi minus 6, that's negative 5 pi over 3. Now to find a positive 1, then I'm just going to add 2 pi, which is 6 plus 1, that's 7 pi over 3. This is positive, this is a negative coterminal. And you keep on doing this, then you can find many other coterminal angles. Okay, so I hope that's clear so far. Okay, so now let's go to the next one. Okay, so the next is we're gonna discuss the length of a circular arc. Okay, so the length of a circular arc in a circle of radius r is the length s of an arc that subtends the central angle of theta radian, which is given by this formula, but I want to kind of explain that here a little further. So this is what they mean. So let's say you have a circle. Okay, maybe I'll just do it without the coordinate plane. So let's say you have a circle. You have a circle. Okay, this is the center of the circle. The angle that subtends the arc is theta. And then what we're trying to do is trying to find, let's say this is A, this is B. So we're trying to find the length of this arc right here. So the length means the distance from one point to another point on the circle. So we're calling this length S. So we're finding, I'll just call the length L. This is what we're trying to find, S. Now one way to do this is, okay, if theta is in radian or degree, okay, let's start with degree. If theta is in degree, then I will do this. I will do theta divided by 360 degree, and then I will multiply by the circumference of this circle. If this is a circle of radius r, let's call it radius r in general. So this will be multiplied by 2 pi r, and that's going to give me what this s is. Well, the reason that they simplify to this is because, okay, if 360 is equivalent to 2 pi, right? This is equivalent to 2 pi. But then 2 pi will cancel, so you get theta times r at the end. If you do it this way, if theta is in radian, then this will always be r times theta anyway, right? But if theta is in degree, then you have to do theta divided by 360 multiplied by 2r. So that's another version of this basically. So this version is like when theta is in degree. When theta is in radian, then you divide it by 2 pi instead of 360, and then you multiply by 2 pi r. But then this 2 pi cancels, so you get theta times r equal to r. That's where this is coming from. And this bottom one is, if you want to find a theta, then you just divide both sides by r, basically. Okay, so I hope that's clear. Okay, now let's do some examples. Okay, so here are a few examples. Okay, so first one, we're gonna find the arc length of a circle. Okay, that radius 10 that subtends 30 degrees. So this is, let's say, 30 degree here. The radius is 10. So I'm trying to find this length here. This length here. So since this is in degree, so then I'm going to do 30 degree divided by 360 degree and multiply it by 2 pi r. And then r is given, so that's 30 degree over 360 degree times 2 pi times 10. So So then this will be, so if I simplify this, this is 1 over 12, 12 times 2 pi times 10. And I can also simplify this. This is 6. So 10 pi over 6, which is 5 pi over 3 meter. Okay, so the length of this arc right here, which is, like I said, it's a distance from this point A to point B. So the length of arc is 2 pi over 3 meter. It's not an angle, it's just a length, distance. So this means it's just distance. We're computing the distance here. Okay, so the next one for part B, so we're trying to find an angle theta in a circle of radius 4 meter is subtended by the arc length of 6. So we want to find the measure of the theta. Okay, so this time we're just going to find the angle given the arc length. Okay, so let's do that. Okay. So that's part B. Okay, so we have a circle here. We're giving that the radius is 4. And the arc length is given. So we're giving this distance here. So I'll just call this S equal to 6 meter. And we're finding the theta. So the theta is unknown here. Okay, so I'm just going to do the same thing. But theta is going to be in radian, right? So theta is going to be in radian. So I will do theta divided by 2 pi multiplied by 2 pi r. And that's going to equal to arc length, which is 6 here. So this 2 cancel. So then you have theta times r equals 6. And the theta is what we're trying to find, and r is giving, so that's 4 equals 6, and then divide both sides by 4, so this is 6 divided by 4, which is 3 over 2 radian. So the angle, the measure of the angle is 3 over 2 radian, basically, in this case. Okay, and there's a similar formula here called the area of a circular arc. So let me talk about that now. Okay, so this one is, okay, so the formula here is again simplified, but I'll tell you more detail here. So let's say you have a circle. Let's say you have a circle. Go back to previous page. Okay. So you have a circle of radius r, let's say. Okay, and this is the angle theta. And now this time what we want to do is we want to compute the area of this slice. So you can call this a slice, area of slice, and it's called a sector, area of a sector. So OAB, so we want to find this area here. Okay, so we know that area of a circle of radius r, area of the circle is pi r squared, right? But I'm just computing this portion of the circle, not the entire circle. All right, so then we do this. If theta is in radian, so suppose theta is in radian, then I will do theta divided by 2 pi, and then I'll multiply this by pi r squared. Okay, that's going to be the area of this sector. So pi r cancel, then you get 1/2 theta r squared, which is the one that is given here. So that means this formula is based on assuming that theta is in radian measure. But theta could be in degree measure as well. If theta is in degree measure, so if theta is in degree measure, then we'll just do theta divided by 360 multiplied by pi r squared. And this will give us the area of the sector. So it just depends what theta is in, right? If theta is in radian, it's just going to be this. If theta is in degree, it's just going to be this formula. Okay, so now let me show you a couple of examples. One of the examples is this. Okay, so now find the area of a sector of a circle with a center angle 60 degrees if the radius of the circle is 3 meters. Okay, so we'll just do this. So I'm just gonna check the angle first, right? Before I start it. This is degree. So if it's a degree, then the area is going to be 60 degrees divided by 360 degrees multiplied by pi r squared, which I can simplify simplify this. So this is 1/6 pi, and r is given, that's 3. So it's going to be 3 squared, which this will be 9 pi over 6. And you can simplify this too. So that's 3 pi over 2 meters. That's the area. So it's quite simple. You just find a number and basically just plug it in.